Before we get started, I want to go over just a few terms and a few things I want to make sure we remember from Algebra 2. Um, so first, let's just talk about a binomial and a trinomial. A binomial has two terms. So an example would be something like x plus y. Or another example would be 2 plus x. Anything that has two terms, one could be a constant, the other a variable. A trinomial has three terms. So for example, x squared plus 2x plus 3. We've got three separate terms. And you notice that these terms that I'm talking about, the terms are split up here by addition, but they could also be separated by subtraction. So addition or subtraction in between those terms. So when I talk about binomials and trinomials, this is what I'm referring to. Also, we're going to be talking about how to multiply today. And so we distribute when you multiply, you distribute a term. But we're going to talk about the order in which you distribute. So we're gonna refer to it as FOIL. So when I say that, I'm talking about first terms, outer terms, inner terms, and last terms. And you'll see what I'm talking about here in just a minute. Oh, sorry, you couldn't see that. So first, outer, inner, and last. All right, so let's get started here with this first example. We're going to FOIL or multiply this together. And I know that it really does not matter which order we do it in, but we're going to do it as a FOIL problem. So first terms, that's the first terms in each of the binomials. We're going to multiply and we get x squared. Then we're going to multiply the outer terms. So x times negative 2 is negative 2x. Then we're going to multiply the inner terms, the 5 and the x, so we get plus 5x. And then the last terms in each binomial, which give us minus 10. And so when we combine these two terms, the inner and the outer, we get x squared plus 3x minus 10. Now what we're going to be doing down at the bottom of the paper, and what this is actually a review of, is factoring. But I want you to see something before I move on, that if I were given this trinomial and asked to factor it, all they're asking me to do is go back to this form. And to do that, I'm going to separate the first terms. Then I'm going to figure out what would give me these middle terms here and what multiplies give me the last. So the easiest ones are the first and the last. These multiply to give me x squared. These multiply to give me negative 10. And then if I put those in place, I can figure out the order and the signs that would make them give me the 3 in the middle. There are lots of tricks to do this. Some people use the box method. There are other little charts that you have probably learned along the way. And if you know how to do those when we get to the factoring, that is great. You're welcome to use them. However, I am not going to teach you a trick. I'm going to teach you something that works for all of these, so that you know how to undo them without having to do a whole separate problem. Because factoring is going to be throughout this course. It does not go away. So you have to know how to factor. And factoring is just undoing multiplication. All right, so I got kind of off track there, but we're going to go ahead and multiply this next one. Remember that when this is squared, this does not equal just x squared plus 16. There is a middle term in there, and I'm going to tell you all year long, don't forget the middle guy. Middleman always seems to get left out. This means x minus 4 times x minus 4, so we're going to multiply it that way. We've got x squared minus 4x minus 4x plus 16, or x squared minus 8x plus 16. All right, so when you see these, don't forget there's a middle guy. The shortcut to get the middle guy is to multiply these together times 2. So if you want to use that, great. But if you can't remember that, just remember to write it out and multiply it. Now on this third one, we can distribute the trinomial into the binomial or the binomial into the trinomial. I'm going to do that. I'm going to distribute my x into each of these terms. So this becomes x cubed minus 2x squared plus x. Just adds an x to each one of them. And then I'm going to distribute the 3 to all three of those terms. So I have plus 3x squared minus 6x plus 3. And then I just combine those terms together. There aren't any other cubes in here, so it's just x cubed. I have a minus 2x squared and a plus 3x squared, so I have a plus 1x squared. I have a plus x and a minus 6x, so minus 5x plus 3. All right, so you may want to pause and try this one before you watch me do it, but it's similar to number 2, so you can just write it out twice, or if you want to try using the shortcut, you can. So I would pause it now, give it a shot, but here we go. So we have 2x minus 5 times 2x minus 5. 2x times 2x would be 4x squared. And then we have minus 10x on the inside, minus 10x. And then the end terms, the last terms, I have plus 25. So I end up with 4x squared minus 20x plus 25. All right, so now we get to the part where we are really reviewing factoring. And so we're going to take these apart, like I was talking about up there with number 1. So they're giving us what you get after you've multiplied. We want to put it back into the 2 binomial terms. Now, the first thing you want to do with any of these problems, any factoring problem, the first thing is to try to factor out anything that they have in common. So factor out common factor. Now this one doesn't have anything that they all have in common, so this doesn't apply. Then I want to look and see if it's a binomial or a trinomial. In this case, it's a trinomial. So if it's a trinomial, then we want to try to undo the multiplication, undo the FOIL. Oh, I'm sorry, you couldn't see anything I was just writing there. So factor out the common factor, which this one doesn't have. And then if it's a trinomial, we want to undo the FOIL or undo the multiplication. So here's how we're going to do that. I want you to look at the first terms. So the first term is x squared, and to get x squared, it would be x times x. Then I'm going to look at the last, and this last term is 8. So what multiplies to give me 8? 4 times 2 gives me 8. So I'm going to put that in my parentheses. Now also 8 times 1 would give me 8, but I'm going to try the 4 and the 2 first. And here's what I want to do next. I know that I want the inner and outer terms to add up to give me negative 6, negative 6x. Well, in order for that to happen, I need negative 4x here, and minus 2, because that gives me a minus 2x on the outside. And negative 4 minus 2 is negative 6. So this is my factored form. All right, so we're going to skip down to number 10 real quick because it's similar to this one. And we're going to take it apart. So same method here. And again, if you want to pause and give it a try and then look at what I did, then that might be a good idea. First, I'm going to try to figure out what gives me a squared. That would be a times a. and I want to figure out what multiplies to give me 6. Now, 3 times 2 give me 6. Well, 3 times 2 would give me 6. Also, 6 times 1 would give me 6. And when I'm thinking about that, I know that 3 and 2 would give me 5, but 6 minus 1 would also give me 5. So this runs into a little bit of an issue here. I'm going to go ahead and put the 3 and the 2 in the problem. Now I want to get a positive 5. Well, I've got a 3a on the inside and a 2a on the outside. And if I add them up, if they're both positive, then I would get my 5a. I also still get positive 6. So this is my answer. But I also want to show you what would happen if I had chosen 6 and 1. So I've got 6a here. I've got 1a out here. I'm trying to get 5 in the middle. A positive 6 minus 1. Positive 6 minus 1 still gives me 5. But the problem is, if I were to multiply this back together, I would not get a positive 6 anymore. I would get a negative 6. So this one does not work. So be careful on problems like that. All right, we're skipping over to the back now because I want to try to do all the trinomials at the same time. So the first thing we're supposed to do here is look for a common factor, something that would divide into all of them. And again, there is nothing in common. So we're just going to try to undo our multiplication. So the first thing we do is try to figure out what multiplies to give us 2x squared. So 2x times x. Then we want to try to figure out what multiplies to give us 3. So we know that 3 and 1 are the only options here. So go ahead and place them in there. It does matter because this has a lead coefficient. Things change. If I were to put my 1 and my 3 in opposite places. So let me show you what I'm talking about. With the original placement, I would have 3x here and 2x on the outside. And I'm trying to get a negative 5 in the middle. So a negative and a negative would give me negative 5. So 2 negatives. And that would multiply to give me a positive 3. So it looks like this is going to be my answer. Now on this one, I have a 1x and I have a 6x. Well, again, that's going to give me 5. I could get a negative 5. Negative 6 plus 1 would give me negative 5. So how do I do that? Well, plus 1 would go here. A minus 3 times 2 would give me negative 6. But the problem is, again, that if I were to multiply this one out, I would get negative 3, not positive 3. So this does not work. And if you need to slow that down and rewind and listen to that multiple times, please, please do, because this is very, very important. Probably the most important topic for you to carry over from Algebra 1 and 2 in order to be successful this year. All right, let's try number 12. And again, if you want to pause, give it a try yourself, and then play the video, by all means do that. This one also is not divisible by anything. They have nothing in common. So we're just going to try to undo it. So we say what multiplies to give us 3x squared? That would be 3x times x. What multiplies to give us 2? That would be 2 times 1. All right, placement is important again. Here I have 3x. Here I have 2x. And I want 3x and 2x to give me a positive 5. They'd both have to be positive. So that means I put 2 positives in here. And that also multiplies to give me 2. And again, placement is important. If you had switched these, it would not work out for you. All right, we have another. Again, pause, try it yourself, and then restart the video. These don't have anything in common to divide out. So we're just going to try to factor again. And we're trying to figure out what would multiply to give me 6x squared. Well, 6 and 1 or 3 and 2. So I'm going to try the 3 and the 2. And then I have to figure out what multiplies to give me 5. So 5 and 1 And that's pretty much it. So placement again is going to be important. And I'll show you the other version of this one just so you can kind of see what I'm talking about. The placement where I have them currently gives me 15x and 2x. I need a negative 13. Negative 15 plus 2 is negative 13. So how do I make that happen? Well, if I want the positive 2, it goes with these to be here. 1 times 2, positive 2. If I put a negative in this other place, negative 5 times 3 would be negative 15. So this would multiply to give me negative 5. This should be my answer. If I had placed those in opposite positions with the 5 here and the 1 here, this would have been 10x and 3x, which also would give me 13. Negative 10 minus 3 would give me negative 13. But when I multiplied, I wouldn't have got negative 5. I would get positive 5. So it doesn't work. All right, we have one more trinomial. And this time we actually do have a greatest common factor, something that we can divide out of all of these, which is just going to be x. So we're going to divide this whole thing by x, or factor out an x. Now you can't just leave it off. It's still there. Even though we're dividing it out of each of them, we have to put it in front. And so we have 8x squared minus 10x minus 3. So I still have to bring down the x, but now we're going to try to take this trinomial that's left over apart, just like we have all the rest of these. So we will have to ask, okay, what multiplies to give us 8x squared? Well, 8 and 1, 4 and 2. So I'm going to try the 4 and the 2. And then we want to figure out, well, what would multiply to give me 3? And it's got to be 3 and 1. Again, placement is going to be important. I'm trying to get a negative 10. So out here, I now have a 12x inside a 2x. I need a negative 10 right here. So I need negative 12 plus 2 to get negative 10. So this part came from the inside, so that's where my positive goes. This came from the outside, so that's where my negative goes. And that would multiply to give me negative 3. So this would be my factored form. All right, so now we're back on the front again. I'm going to go back to the ones that were binomials. So on the binomials, the same rules still apply to begin with. We want to factor out anything that they might have in common, anything that I could divide out. And on number 6, it looks like these are both divisible by 3. So I'm going to factor out a 3. It still has to be there in the front, so don't leave it out. And if I divide by 3, then I have h squared minus 16 left. Well, h squared minus 16 is a difference of squares. And you may remember that from Algebra 2. What that means is that this is a perfect square, h times h, and this is a perfect square, 4 times 4. And so if I wanted to continue factoring that, I can just use that difference. H times h would give me h squared. 4 times 4 would give me 16, but I don't have a middle term like I did on those trinomials. So what I want is a 0. Well, 4h on the inside and 4h on the outside. Well, to get a 0, one needs to be positive, one needs to be negative. So I just have a plus and a minus. And then they zero out, and I don't have a middle term. So this would be the factored form. Now you can only do that when these are perfect squares, a difference of perfect squares. All right, so let's look at number 7. It looks like they also have something in common here. They have the number 5 that we could divide out and an x. So I'm going to divide this by negative 5x. We'll get rid of that negative out in front as well. So I'm going to put the negative 5x out in front. If I divide negative 15 by negative 5, I get 3. x squared divided by x is just x. And then negative 5x divided by negative 5x would be positive 1. Now here's what I'm talking about. What I have left over this time is not a perfect square. There's nothing here that is going to factor again. So on this problem, we're finished. All we had to do is pull out the greatest common factor. Okay, for number 8, start off with our greatest common factor. Want to figure out what they have in common. They both have an x in common, divide by x. Pull that out in the front. So x squared divided by x is x. 3x divided by x is 3. And again, those are not perfect squares, so that's it. That's as far as we can go. All right, and one more. For number 9, 16 and 169, I know those numbers are getting large, but there is nothing that will divide into 16 and to 169. So these don't have a greatest common factor. So the next thing we want to try to figure out is if they are perfect squares. Well, 16 is 4 times 4. R squared is R times R. 169 is 13 times 13. So these are perfect squares. So we can undo them like we did the one up above. This would be 4R times 4R. 169 is 13 times 13. I want one of these to be positive, the other one to be negative, so that they zero out, and that would be my factored form. So we're going to be doing factoring for a couple of days because, like I said, this is very instrumental in being able to accomplish everything we're going to do for the rest of this semester, really the rest of the year, because even when next semester when we're doing trigonometry, we have to know how to factor. So if you are not good at factoring or you've never learned how to factor, this is your time. This is your year, because we need to get it done now so that you're not lost when we're doing some other things.